Use the substitution method to find the simultaneous solution. When I first look at the equations, I want to choose one of the equations and solve it for a particular variable. When deciding what equation to use, it is best to look for a variable that has a coefficient of 1 or -1 to solve for it. So if I'm looking at the first equation, I could choose to solve for either x or y because both of them have a coefficient of +1. If I wanted to look at the second equation, I would probably choose y as the variable to solve for because it has a coefficient of -1. I could actually choose x, but keep in mind if the coefficients are anything other than 1 or -1, I might end up with a fraction in the system of equations, and sometimes it might be a little bit more tedious to work with, but it still works. So I'm just going to start with the top equation, and I'll just make the decision that I want to solve the top equation for x. So if I do that, let me rewrite it really quickly so we can actually see what's going on. And if I solve it for x, that would involve me subtracting y on both sides. So I could get x equals 5 minus y as my new equation. I'm just going to circle that for a moment. So I solved the first equation for x, and I got an equivalent equation, x equals 5 minus y. At this stage, you will want to plug in the 5 minus y for x in the second equation. Now make sure you're plugging the first equation into the second equation and not back into itself. That will cause some problems with your solution. So I'm looking at 2x minus y equals 4, and I'm going to substitute in 4x. So that will leave me with 2 times, instead of x, we'll substitute this with 5 minus y. So that leaves us with 2x. Keep in mind the format of your equation. You have a minus sign that you have to account for. And then you also have to keep track of the fact that you have a y to rewrite as well. An equal sign. And the 4. Just want to show the consistency there. So 2x minus y equals 4 becomes 2 times the quantity of 5 minus y equals 4. So at this point, you notice that you have equation in only one variable, and these are the equations that we'll try to solve. So if I'm going to solve for y, I'm going to distribute the 2 to the 5 and the -y. So that will leave me with 10 minus 2y, rewriting the minus y equals 4 from the rest of the equation. And then I'll combine like terms, the -2y and y. So that will leave me with 10 minus 3y equals 4. And if I'm going to move the 10 over to the right-hand side, I'll subtract 10 on both sides. And that will leave me with -3y equals -6. And to finally isolate y, we'll divide both sides by -3. And that will leave us with y equals 2. So that is the solution to this equation, and it's actually the y value of our system. So I'll circle this. And now I'm ready to try to find the value of x. Now keep in mind, if you know y, you can plug it back into any of the original equations to find the x. Or we might find it a little bit more convenient if we plug it back into the equation where we solved for x already. This is essentially the first equation, but since it's already solved for x, it causes a little bit of less computation to do. So I will do that. So if I'm plugging in y equals 2, that will leave me with x equals 5 minus 2. Again, the y was equal to 2. Just want to point that out. You're resubstituting this in. And so then you just compute the value of x. We can simplify this as x equals 5 minus 2 is 3. And so that gives us our x value of the system. So if you want to write your answer as an ordered pair, remember that your solution would be written where the x goes first. So that would be 3, comma, 2. And that's the solution to our system.